These are the 2.2 notes for pre-calc. We're going to first start by talking about even and odd functions, and on the back side of your notes, average rate of change. So even and odd functions have a lot to do with symmetry. If we have a graph that is symmetric to the x-axis, it means that it's going to look the same at the top and the bottom. So something maybe like this. That is x-axis symmetry. But if you remember the vertical line test, we are not allowed to have a graph kind of pass over itself. So if you think about a vertical line, it fails that test. So that means that is not a function. This chapter is all about functions, so we are not going to be dealing with those types of problems at all. The next one is something that has y-axis symmetry, so maybe something that looks like this. And the y-axis cuts it right down the middle. They call this an even function. Something that is symmetric to the origin, maybe that goes through here, like that. You have the same thing in one diagonal corner as the other, is symmetric to the origin. And this one they call an odd function. So at least origin and odd have that same letter O, so you can remember that those go together. Origin and odd. So if you're looking at a graph, you just have to basically tell the symmetry. But a lot of times we don't have the graph. So for example 1, 2, and 3, we are going to come up with a different way to identify what these look like. So the shortcut is, if you have all even exponents, it means you have an even function. All even exponents. Also, if there's no x, like if you just have a constant number like this 8 right there, that's the same as having x to the 0. So no x means x to the 0. So everything has to have an exponent on it so you can compare them. So example number 1, notice you have a 2 and a 0. That is an even function. Here you have an exponent of 4. That is an even function. This last one is a 6, a 2. There's no x here, so I'm going to put x to the 0. 6, 2, and 0 are all even functions. I'm going to show you what this last one looks like on a graph, just so you can see it. So right here, I just plotted x squared minus 2x, x to the 6 minus 2x squared plus 1. And notice you have this y-axis symmetry. The y-axis cuts it down the middle, and it looks the same thing on the right as it does on the left. That is your even functions, kind of like this one up here. All right, for your odd functions, it's when you have all odd exponents. The thing we need to remember here is if it has an x, you need to make sure you put x to the first power. You need to fill in that 1. So on this first example, you have 2x to the 1, so you have a 3 and a 1. 3 and 1 are both odd numbers, so this is an odd function. 7 is odd, that one's odd. The 5, the 3, and the invisible 1, those are all odd, so that is an odd function. That means it's going to be symmetric to the origin. So that's the second one right here. Notice how it's symmetric to the origin. What you have in the top right corner is the same as what you have in the bottom left corner. Same thing happens if you zoom out. All right, then you have the rest of these. This is a combination of even and odd. Combo of even and odd exponents. So a mixture. Not all of them are even, not all of them are odd. That's when it's neither. So on this first one, I have a 7, a 1, and a 0. 7, 1, and 0. 7 and 1 are odd. 0 is even. That is neither. Here I have a 6 and a 3. 6 is even, 3 is odd. That's neither. Same thing on the last one. Let me show you that last one graph just so you can see. Looks like this. So it's a parabola, and it almost is centered, but not quite. Notice how it's a little bit off. So that would be an example of something that's neither. So now on problem number 4, I want you to decide whether each of these is even, odd, or neither. And just write down the word even, odd, or neither. I'll give you just a moment. The first one is even. You have a 4 and a 2. The second one is neither. You have a 1 and a 0. The third one is neither. You have a 5 and a 0. The last one is odd, x to the 1. The next part has to do with average rate of change. Average rate of change is very similar to slope. Slope is with a straight line, and average rate of change can be with any other shape. So the average rate of change formula looks very similar to the slope formula. It's just in function notation. B minus A. Okay, so example number 5, this is our function. So anytime they're referencing f, that's what we're talking about here. And 1 is going to be our a and our b. And sometimes they'll write it like this. That means the same thing. It's still a and b. So I'm going to set up my problem like this. I'm just going to go ahead and plug in my a and my b. So f of 3 minus f of 1 over 3 minus 1. And then I'm going to do the f of 3 off to the side. So f of 3, I'm going to plug in a 3, just like that. 3 squared is 9, and 2 times 9 is 18. I'm going to do the same thing with f of 1. 2 times 1 squared, square the 1, multiply to get 2. So then I can write this as f of 3 is 18. I already did that work. F of 1 is 2 over 3 minus 1. 18 minus 2 is 16. 3 minus 1 is 2. And I get a final answer of 8. That's my average rate of change, or in other words, the slope. For the next one, set it up the same way. So we would do f of 4 minus f of 0. So that's your a and your b over 4 minus 0. Again, kind of come off to the side. I have space over here, so I'll do that. F of 4 to the third power minus 2. That's 64 minus 2, which is 62. I'll plug that in right there. Do the same thing for the 0. F of 0. 0 to the third minus 2. 0 minus 2. Negative 2. So I'm going to subtract negative 2. 2 negatives make a positive right there. And I get 64 over 4. And 64 divided by 4 gets me 16. So I want to show you one where it doesn't always get you a whole number. Most of the time it does, but not always. So we've got our our B, A and our B. All right, so we've got f of 25 minus f of 4 over 25 minus 4. Come off to the side to do the work. I'm going to plug it in where I see the x. Square root of 25 is 5, so that's 3 times 5, 15. Take the square root of 4, 3 times 2, gets me 6. So f of 25 is 15 minus f of 4 is 6 over 25 minus 4. gets me 9 over 21. That doesn't divide into a whole number, but it does reduce. I'll reduce it by 3, getting me a final answer of 3/7. So sometimes you do end up with a fraction for average rate of change. If you have questions, let me know.